Hello everybody. In this video I will talk about data structure. Data structure is a simple way of organizing data. Such that accessing and manipulating data is easy. There are several different kinds of data structure defined like array, stack, queue, linked list, tree, graph, etc. are examples of data structure. There are two types of data structures generally. Data structure. Linear data structure. In linear, array, stack, queue, linked list, and another is non-linear. Tree, graph are example of non-linear data structures. Array is a simple kind of data structure. In array, elements are stored sequentially one after another in a memory location. Array index always starts from 0. Let's say a simple example. Let's suppose this is an array and it contains elements like this. In array, random access is possible. This 22 starts at 0, this 33 1, 44 2, and so on. If you know the position of element, then directly we can access that element. But in array, if we have to insert new element in between existing element, that will be a time consuming process. That is, if you want to insert new value that is 27 between 33 and 44. Suppose we have to insert new value 27 between 33 and 44. What do we have to do? Simple. We have to shift these elements backwards, one step backwards. Okay, we have to do it like this, simple, and make empty position for new element. Then only we can store new value in between existing elements. That is a time consuming process. If there are lots of elements and we have to shift lots of elements, that will be a very time consuming process. Similarly, if we want to delete element from the array, suppose we want to delete 44, what we can do is simply we can remove this value and this we can leave this position empty. That means there will be a waste of memory space. Or what we can do is we can bring back these elements one step forward and fill the empty position. And again, this is a time consuming process because we have to shift elements forward. So whatever it may be, array linear data structures, it helps random access, sourcing will be fast. But when it comes to manipulating data within the array, it will be a very time consuming process. So in order to eliminate or recover this limitation of the array, linear data structure linked list has been defined. Linked list, that is the linear data structure. Data in linked list, data are stored in nodes. Node contains two parts. One is data part and another is address part. Data part contains actual data and address part contains address of next node. Let's suppose we are having a node like this. This is a node. It will have two parts. Let's divide this. No, delete. Not happening. Okay. In this way, we can divide the node, and one part will contain data like 44 we have stored in the data part. Another part will contain address of, this is the data part, this is the address part. It will contain address of another node. So let's make a simple linked list. Let's delete these things. Let's group this. Okay. Okay, now Control C, Control V, Control V, Control V. Now in this way we can make the nodes. And these nodes are not stored sequentially. They will be stored randomly in the memory locations, not sequentially. Let's suppose this is 55, this is 66, 77, 88. Now these will be connected like this by the reference. 44 will contain reference to 55. 55 will be connected to 66 like this. 66 to 77. 77 to, and these nodes are stored not sequentially in memory locations. They will be stored randomly in memory location. It's not like in array. Now if you want to store new element in between, suppose 55 and 66, suppose this is our new element and containing value 99. What we have to do is just simply we have to switch the pointer, delete this reference between 55 and 66, connect 55 to 99 like this, then connect 99 to 66. Simple. No shifting has to be done. Just we have to find the position where we want to insert the element, then just switch the pointers. So that is a very efficient method of inserting data. It is not like in array where we have to shift lots of elements, which is a time consuming process. Similarly, if you want to delete element, we can delete element. Let's suppose we want to delete 55. Remove this. Then just what we have to do is we have to switch the pointers or switch the references of the objects. Just connect 44 with 99. In this way, we can efficiently efficiently remove element from linked list. So linked list enables manipulations, accessing data easily. In linked list, it is random access is not possible. Only linear sorting is possible with linked list, and it is compulsory for us to know the address or reference of first node in the linked list. If we know the address or reference of this first node 44 in this example, we can access remaining elements sequentially. We can, after 44, we can go to 99 and 66, 77 and so on. In this way, we can access elements sequentially in the linked list. Thank you for watching this.